Hey everyone, sorry for the delay. Actually, not at home. I just came, and also the current is like light has gone because the weather in Hyderabad is not very good. So I am not turning on my video because you cannot see me. It's dark right now. But yeah, let me know if you guys can hear me properly because I'm not sure if I'm using hotspots or there might be a lag in audio and these things. So yeah, let me know if you guys can hear me well. Can someone tell in the chat like if you can hear me properly? Can anyone in the chat tell if you can hear me properly or am I not audible? Okay, voice is clear. Thanks a bit. Awesome. So yeah, without as you understand, the situation is pretty worse. So we cannot waste a lot of time right now. So let's actually get started without I would only request you just to give maybe your 100% because again I want to get it completed fast. Because that will benefit you as well and me as well because I don't know like how long the internet will be holding up or my device will be holding up. So no, last week's I cannot discuss today because again like the situation is not very good. Let me discuss it next class maybe, if once the situation is better. All right. So let's do that. Otherwise, for today what I was thinking is, instead of doing like all three, the first one is pretty simple. It's like reversing a linked list. So I'm not going to discuss reversing a linked list anymore. So let's actually start from the second and try completing the second and the third problem because those are more important, right? Like the first one is reversing a linked list and you will find lot of solutions online. There are a lot of videos as well online. In fact, in Geeks for Geeks itself you'll find a lot of videos for that. So let's directly go to the second and the third question. Like I hope you understand the situation, right? So coming with the second question quickly. So what it is given to us is we are given a string s, right? We are given a string s. The string can contain small English characters or question mark. You can replace question mark with any small English letter. Now if it is possible to make s a palindrome after replacing all question mark, then find the adjacent string, find the palindromic string with minimum sum of differences of adjacent characters, right? So it is said that we are given a string s. In s, some of the characters are question mark and some of the characters are there like a to z small English characters. Now what we have to do is we have to check if we have to convert it into a palindrome, right? Not only that, we have to convert it into a palindrome such that the sum of the difference between adjacent characters is the minimum, and we have to return that difference, right? Sum of the difference. And if it is not possible to be converted to a palindrome, we will just return -1. Okay. So we have a question mark question mark question mark c question mark question mark c question mark question mark question mark question mark. So here what we can do is we can replace like what are possibilities, right? We can replace this question mark with maybe b, c, a, anything, right? So let's understand like what would be the difference. So let's say we replace all these question marks with a here. So this question mark is let's write it down, right? Let's write it down. So we have a, then we have three question marks, question mark question mark question mark. Rather, instead of question mark, let's just put blanks, right? A blank blank blank. Then we have c. After c, what do we have? After c we have then we have double blank, then we have c, then we have four blanks, right? So this is the string, right? Now to make this palindrome, like what do we do when we convert a string to a palindrome? We'll start from both the ends, right? Okay, so uh, let me see the chat if you have. Okay, so we start from both the ends, right? We start from both the ends. Now for the first one and the last one, like a should be coming here because it is the palindrome, right? So both, like from the forward, how you see it, it should be same you read backwards. So a should be coming here as well, right? So there is no choice here but to fill a. Now let's come one step. So we'll come one step here and we'll come one step here. So now in the next we have blank in both places, right? So we have choice to put anything. We can put A, B, C, D, E, F, anything up to Z. What we'll do here is, the logic is, we'll always try to keep the same thing, right? So we'll try to keep the same thing, because see, anyways, like if we keep let's say we are having any character here, right? We have to jump to C. So anyways, like jumping, we are eventually jumping from A to C, be it using A, B, C like that, like two changes, or making one change from A to C directly, right? So both will be like, we have to climb up, kind of like it's kind of a stair, right? So we have to climb up by two steps in any ways, right? And it doesn't make sense to go to from A to D to C, right? This doesn't make any sense. That will increase the cost. It will make sense to go from A to C, A to B to C, or A to C, again A to C directly. So in any case, the cost will be always 2, right? We will be climbing up, or will be creating a difference of 2 in any case. Basically, like when we go from A to B to C, A to B will create a difference of 1, B to C will create a difference of 1, so 2. But A to C will create a difference of 2 directly. So we can take any of these. So we'll always prefer keeping the characters same, right? We'll always prefer keeping the characters same. So we can place anything here. A, let's place A. Next place, again let's place A, right? Let's place A here again. Next place, all right, next place as well we can keep A. So A. Next we have C. So C, and we have a C here again. So we'll add 2 into whatever is the character difference. So 2 into 2, that is 4, right? 2 into 2 is equals to 4. Next we'll update our last character. The last seen character now is C, right? So in the next place we'll not keep C, right? We'll not keep A, we'll keep C. So we'll keep C, and the answer will be 4, right? The answer will be 4. uh, okay, we'll see, like we'll see if the code is turning out to be wrong. It might be happening that it might happen that the test cases are not good. So we'll check, right? We'll try to write the code. I haven't myself written the code, so we'll try to get it done. All right, so we have 2 into 2, 4, and this will be the logic, right? So again, the logic will be, what we'll do is, we'll try to keep the character same. We'll travel from both the ends. Simple, will travel from both the ends, because we have to form a palindromic string. Now if one of the ends, one of them is given, right? If A is given to you first, there might be cases where it is like AC is given to you already. In this case, you have to return -1, right? You have to take care of this, that what is given to you, that is already a palindrome. You have to make sure of that, and only after that this algorithm will work. There might be cases where it is given to you like A something dot question mark question mark question mark and then C, right? In this case, you cannot do anything, right? uh, what if the start and end? Yes, it can be start and end at question mark. Like, we do not care about what start and end is. We just think about it. We are not actually writing down what each character will be, right? We can fill each character, but we do not need to. We just need the difference, right? So for the first, like let's say there are some question marks, and after that there is a and some question marks here, right? And maybe something here later on, right? So in this case, we will see question mark, and we'll have some delimiter that will tell us that we haven't seen a character yet, right? So that will be a delimiter. So when we reach here, we will know that the last character that we have seen is nothing. We have not seen any character, so we will not add anything to our difference. But here we'll update our last character to A, right? Last character to N, and we'll assume that it is already filled with A. So we'll not add anything to our answer. Now let's say there is a C somewhere here, right? There is a C somewhere here. So we know that here we have to fill A. So the difference here will be now accumulated to like 2, A to C jump, right? Okay, A to C will be jump. What if same thing, A, you start from both the ends. Now here you go to the next place. Here you see like what is the last character that you have seen, A. So you'll just place A, and the answer will be 0. So this will also work, right? So this should also work. So yeah, like most of the cases should work, but we'll see, like if it doesn't work for something, we'll see, like there might be the test cases might be wrong. For A, it should be like just you should return 0, right? This should be 0, just if it is already palindrome. If it is not a palindrome, let's say you are given something like this, A and then C, this should return -1, right? This should return -1. So that's the logic. So we'll try to write the code for this now. All right, let's try to write the code for this. So what we'll do is we'll keep two pointers, right? Int ptr1 equals to 0, ptr2 equals to s dot size minus 1, s dot size minus 1. So we keep two pointers to start from the two ends, right? The compiler was giving 68 as output of, hey, let's see, let's test it out. So a question mark a, if we give this expected output, if that's the case, okay, it is giving 68, then the test cases are wrong probably, so I cannot do anything about that. But yeah, like it should not be 68, it should be 0. It should be 0, so I think the test cases are wrong. I have to talk to the team about like having good problem testers. But anyways, it should be 0, it should not be 60. ptr1 is 0, ptr2 equals to s dot size minus 1. I hope it's not, cannot be. So ptr2 is dot size minus 1. So we have cad last seen character. Let's say we keep the delimiter as something like what should be the delimiter? Star, maybe star or something like that. uh, okay, so start and int answer, right? Answer equals to 0 initially. So again, like this code will definitely not run because if the test cases are wrong, but let's invest, right? So if ptr1 less than while ptr1 less than equal to ptr2, right? While ptr1 less than equal to ptr2, now we'll check here, like if uh, if s of ptr1, if s of ptr1 is equals to question mark, and s of ptr2, if both of them are question mark, is equals to question mark, right? So in this case, if both of them are question mark, will most likely carry whatever we have seen till now. So we will do ptr1 plus plus, ptr2 plus plus. Else if both of them are, one of them is question mark, if ptr1 is equals to question mark, that is ptr2 is not question mark but ptr1 is question mark, right? Because if both of them are question mark, it will satisfy this condition. So else if ptr1 is question mark, in that case ptr2 whatever is there, that will be carried forward. So basically our last thing, uh, uh, and again we'll have a check here. If last seen is equals to start, that means this is the first character that we have seen, so the previous characters will be like having the same value. Like if we have a now, the previous characters would also have been a, right? Last seen equals to start, then we'll just update our last seen to like current s of ptr2, otherwise and will not do anything. Else, in the else case, what we'll do is we have to accumulate the difference of the characters, right? Answer equals to answer plus equals to uh, abs, abs of what? Abs of last seen minus s of ptr2, their difference, right? How much step we are moving, and also last seen we have to update to a of s of ptr2. So s of ptr2, so that will be the case when s of ptr1 is equals to question mark. Else if s of ptr2 is equals to question mark, so else of ptr2 is equals to question mark, ptr2 minus minus, okay, ptr2 plus plus I've written, sorry, ptr2 minus minus, this one. And also here also we have to do, like I think in every step we have to do ptr1 plus plus ptr2 minus, right? So let's just do it, right? Let's just write everything separately. So ptr1 plus plus ptr2 minus minus, we have already done that last scene. And now next, s of ptr2 is equals to question mark. So in this case will again it will be same, only s of ptr1 is there, s of ptr2 is not there. So s of ptr1 will it be, and here it will be last seen minus s of ptr1, and last seen will be s of ptr1 and ptr1 plus plus. And finally else is the case when both the characters are present, right? So in this case only we'll check if s of ptr1, if s of ptr1 is equals to is actually this is not true, right? This will be not true. Why this is not true, I'll come back in a bit. So s of ptr1 is not equals to s of ptr2, we will directly return minus 1 from this, return minus 1, right? Otherwise we'll do ptr1 plus plus and ptr2 minus minus. Okay, ptr2 yes, Yes, now we have to take care this. What we are doing is we are accumulating the difference only once. But if you think about it, the difference will be happening two times, right? Difference is happening two times. The first time is for the left part ptr1 to the next one, or the last character to ptr1, and also for ptr2 as well, right? On the both the ends it will happen. Only for one case this will not happen, right? Only if the element is the middle element. If the current element is the middle element, only then it will not happen, right? If the current element is the middle element, right? So what we can do is, if we can check here, if ptr in fact, if the current element is middle element, this condition would never come, right? I don't think this condition can never come. Only this condition should come. And here also we have to add it to our answer. So actually here it will work, but just one second. Why did I do anything? ptr2 last scene. If okay, let's remove this. Here it will never come. It will come in this case. Here also we have to accumulate, like, although this is a character present, but we have to add to our difference, right? This will add to our difference, because let's say there was a and currently both of them are c, so a to c, that difference we have to add. Now here we have to check for middle element as well. If ptr1 is equals to ptr2, right? If ptr1 is equals to ptr2, let me just think about it once. If it is question mark, then fine. uh, Otherwise, for middle element question it should work. Yeah. If ptr1 is equals to ptr2, what should be there? If ptr1 is equals to ptr2, s of uh, okay, ptr1 is equals to ptr2 answer plus equals to abs last scene. If last scene, right? uh, Again, if first of all, if last scene not equals to start, if ptr1, if ptr1 is equals to ptr2, s of ptr1 rather, if s of pt sorry, not ptr1 equals to, or else, right? If ptr1 is equals to ptr2 answer plus equals to abs last scene minus s of ptr1 only one time, or otherwise answer plus equals to abs last scene minus s of ptr1 into 2. So every time it will be into 2. So 2 into this, and here also every time it will be into 2. 2 into this and 2 into this, right? ईडिक तो भाई पागल हो गया लास्ट कॉन्टेस्ट को लेकर. So we haven't returned the answer, right? So return answer. My bad. So return answer. Okay. Return answer. Let's compile and run this. And okay, our output is 0, which is, I think, expected output should be 0 in this case. Let's actually see. It should be 0, right? I'm not sure if the judge would work, but yeah, like it should be 0. Should be 0. So it's giving correctly for this. Let's try this sample case, right? The sample case that's given to us. Let's try that, and maybe let's try a few other cases before we submit. So it's giving 4. That's correct. Do we want to try anything else? Let's see. Let's try this. It should give -1. Let's try a -1 case as well. Does it like take care of that? And then let's try another. -1 is working fine. Maybe let's try something like this, that we have two this, then a, then blank, then we have a c, then we have some blanks, blank, 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 right? C. So let's see the expected output. So it should be 1. Sorry, it should be 2. It should be actually not 2. It should be 4. For the middle element as well, we should actually do. Sorry, output of online judge is 0. How is it 0? A there it will not be 0. Correct answer. But what's our output? Let's see. My output, it should give 4 actually, but I think we should do into 2 here as well, because the difference is accumulated from both the ends. Yes, we should do 2 into here from as well, because see what it will be: a c a. So a to c one difference and c to a again difference, so 2 plus 2 will be 4. So it should be 2. Or is it talking about the negative, like uh, minimum sum of differences of adjacent characters? B, a to b, right, a to b. Okay, they're not taking. All right, that should be the case, but it should not work. Online judge, it is not working. Online judge, we have already seen a has, it is not even working for this case as well, right? The test cases are wrong, so online judge is not working. But yeah, like this should be the algorithm. 68, it is giving 68, but my code will work fine, I believe. It should give 0. Please like rewatch the video, like if you have missed. अरे मानव कर रहा हूँ ट्राई भाई, कितना बार बोल रहा है, क्या ना. अच्छा अभी दिख रहा है मे बी, इसलिए ऑनलाइन जज विल नॉट वर्क फॉर दिस. But this will work, like this code is working. So again, like this should be the correct code. The test cases are wrong, so we cannot do anything about this, right? At least I cannot do anything about this right now. But yeah, like that should be the logic, right? So the logic is simple, like you try to keep the character same as long as you can. Whenever there is a difference, that time you adjust the difference, like whatever is the answer plus equals to the difference, and then you carry forward. Why in the first example they took b instead of a? It's same thing, right? Like that's what we discussed first actually. If you take like the c, you have to jump from a to c. You have to jump from a to c. You can either jump directly from a to c, or you can jump from a to b and b to c. The total difference, the net difference remains the same, so you can take both the routes. It completely depends on you which route you want to take. For us, for writing the code conveniently, it makes more sense for us to go this way, a to c, right? But you can go, this is also a valid solution. This is not at all an invalid solution. This is also a valid, but this will not be a valid solution. A d c c, this will not be a valid solution, right? Or a d c, like you are going beyond c and then you are again coming back. This is not a valid solution. The step up, the next step up will remain the same. You have to go from a to c, be it a to c directly or a to b to c, right? So it doesn't make any difference. Both of them, the answer is same, but the answer will be the same, right? 4 will be same, be it abc or a to c directly. So that's the second one. We cannot do like it's not the test cases are not working. No, I have already tried, the code was not working. I have tried submitting, code is not working, so the test cases are wrong. So nothing, it's wrong, don't worry about it. You are right. You if you had solved it, you are probably right, your code was probably right, but test cases are not right. So we have so last question, we are given an array a of length n. You have to make the array stable. Definition of the stable array is: a array is called stable when there exists a number x such that every number from the array occurs only x times or 0 times, right? So you are given a stable array. So what is a stable array? A stable array is an array where there exists a number x such that each element exists x times, right? Your task is to find the minimum number that needs to be removed to make the array stable. So how many elements do you have to remove from the array so that it is a stable array, right? You cannot add elements, you have to remove elements. But test cases are not working. Let's understand this. Let's try to understand how this will work. Actually, this is a very simple problem, right? Honestly, this is a very simple problem. I'll tell you why. See, so you are given an array A, and what you have to do, in fact, this is easier than the last problem, right? So what is said to us is, there exists a number, like there is some number x, each element will happen x times. You have to find what is the minimum number of elements that you need to delete such that all the elements have the same frequency. Basically, all the elements have the same frequency. What is the minimum number of elements that you have to delete, right? So that is the question. How is that possible? I'm not sure how is that possible. Maybe they have done in some hacky way or something, but or maybe I have understood the question wrong. But as per the test case, the question, how I did it seems to be fair. I'm not sure. Uh, Different test case, but they're giving wrong. All right, let's see if it is giving wrong for me as well. Might be for this as well. So 1124, again, like 431312, right? So what is the frequency of 4? 1. What is the frequency of 3? 2. What is the frequency of 1? 2. What is the frequency of 2? 1. So either we can remove 4 and 2, two elements, and we can make all the frequencies 2, right? So the output will be 2, right? Similarly here, 1124 122, the output will be 1 in this case, because here one frequency is 3, two frequencies 3, only four frequencies 1, so we can just remove 4, and all the frequencies will be 3. So we just remove one of them. Okay, so that's the question. Let's see how we can solve this. The solution is pretty simple, actually pretty straightforward. uh, One thing to note is, whatever the value, like each element will occur x times, right? Each element occurs x times. This x will always be the frequency of any element. Any element of the array, all the elements that are there, let's say 2 occurs 5 times, 3 occurs 4 times, 4 occurs 3 times, something like this. The frequency of one of the elements will be x, right? The frequency of one of the elements will be x, and we have some x. What is the op- once we have fixed some x, what is the, how do we calculate the answer? Let me know if the stream is running. Can you guys hear me? Okay, 1000. I think we are there. Let me know if you guys can hear me properly. Okay, you guys can hear me. All right. All right. All right. Thank you. So, all right. F of element minus x. So we have, yeah. So we need a sweet spot, right? We need a sweet spot of these elements, right? Like we want to find a frequency, which is the frequency of any one of the elements, right? Which can be any one or more elements. We want to find a frequency f such that this is minimized, right? Like the total sum, like the total number of elements removed, that is minimized. So how do we do this? How do we do this is, first of all, we'll find the frequency of each of the elements, right? First of all, we'll find the frequency of each of the elements. So let's take the example. Let's take the example of this first example, 431312. 431312. So let's take the example 431312. What is the frequency of 4? The frequency of 4 is 1. The frequency of 3 is 2. The frequency of 1 is 2. The frequency of 2 is 1, right? So we have the frequencies. We'll store the frequencies in a table. After this, the elements doesn't matter, right? Their frequency only matters, the element doesn't matter. So we can store them in a array like this, 1 1, in a sorted way, 1 1 2 2. Now let's go through each of them, right? So for the first element, if we were to keep the frequency x to be 1, how many elements are to be deleted? So first thing is, how many elements have frequency less than 1? Those will be deleted. So how we can find that? We can just binary search for how many elements, like lower bound. Basically, what is the lower bound here? So the lower bound will be like this itself. So number of elements less than 1 will be 0. Number of elements whose frequency is greater than 1, that will be like here, this 2 and 2. So 2 and 2, from them what will be subtracted, right? So 2 and 2, those will be brought down to yep, those will be brought down to what will they be brought down to? Okay, so just one second. So 0 we have, and for these we will bring down their frequencies to 1, right? All the elements greater than, their frequencies will be brought down to 1. So basically, okay, this is how we'll do this, that these are gone, right? Now the elements that are remaining, n, the total size one was n, right? So the total size was n. How many elements will be remaining, that is what we'll figure out, right? Which are the elements that will be remaining, because we know their frequencies. We know their frequency, that will be 1. So 1 into, we have to know what is the elements that will be remaining. So for the elements that will be remaining, their frequency has to be greater than equal to the frequency. So that is this position only. So all the elements will be remaining 1, 2, 3, 4. 1 into 4. So n minus 4, that is n minus 4 is n is 6. I think 1, 2, 3, 4, 5, 6. N is 6. 6 minus 4, that is 2. So 2 elements will be deleted, and that is in fact true. Like 1, 3 or 1, 2 can be deleted. Now let's go to the next element 1. Again 1, for the 1 again the same case will happen. For 2, now how many elements will be deleted? First of all, we have to find what are the elements that will be remaining. So only the elements whose frequency is greater than equal to 2, they will remain. So what is the position here? These elements, so these 2 and 2. So there are 2 elements who will remain. And what is their frequency? How many times will they remain? The frequency is 2. So frequency is 2. So 4 elements will be remaining. How many elements we had initially? 6. 6 minus 4, that is 2 elements will have to be removed, right? So 2 elements will have to be removed. So the answer here will be 2. So again, the logic will be pretty simple. First of all, calculate the frequency. Calculate frequency and store in a array. Then sort the array. Sort array. Then third is for each, right? For each element, what we should see. For each element, what do we want to see? For each element we want to see, one second, what do we want to see? We want to see for each element in the array, that is the frequency, right? So how many elements do we need to delete, that we want to calculate. So we know let's call the element, current element is x. So we know all the elements will have a frequency of x. And which elements will remain? Which elements will remain? The number of elements whose frequency is greater than equal to x, right? So x into number of elements whose frequency is greater than equal to x, they will remain. So x into these many elements will remain. And how many elements were there? N elements. So this, right? So the minimum answer we want, so minimum of this, right? Minimum of answer comma this thing. So this will be the logic, right? This will be the logic. So what we can do now, let's write the code for this. So okay, vector int frequencies, let's keep the frequencies, and let's maintain a map int hash map. So for int x belongs to a, hash map of a x plus plus, right? For auto v belongs to hash map, we'll store the frequencies only, frequencies dot push back. So frequencies dot push back, frequencies dot push back v dot second. V dot second will be the frequency. So each element in the hash map or in a map will be stored as a pair of key value pairs. So the value is the frequency. So v dot second will push. Then we'll sort the array, right? So sort frequencies dot begin, sort frequencies dot begin, frequencies dot end. And now we'll take the answer equals to 0. In initially answer, let's keep it high, right? Initially answer, let's keep it high, like it should be n plus 1. Like n plus 1 will n plus 1 means we have to delete all the elements, kind of, right? So that is the maximum possible answer. So and n is not defined, so let's define n as well here. So n equals to a dot size. And here what we'll do, we'll go through all the frequencies. So for int x belongs to frequencies, okay, int x belongs to frequencies. Now we want to find the index where so what we are finding here, how many frequencies, what are the frequencies, rather frequencies, or how many elements, rather how many elements have frequency greater than equal to x, right? How many elements have frequency, because we are storing the frequency of each of them, right? How many elements have frequency greater than equal to x, right? So lower bound, that is what a lower bound gives us. Lower bound frequencies dot begin, frequencies dot end x minus frequencies dot begin, that will give us the index, right? That will give us the index. So these many elements have frequency greater. So how many elements are there? Index is given to us. So num elements will be what? From this index, we have all the frequencies greater than equal to x. So it should be n minus index should be the num elements, I believe. N minus index, right? So from this index, all the frequencies are greater than equal to x. So number of elements is n minus index. Answer equals to mean answer comma n minus num elements, number of elements whose frequency is greater than equal to x, into they will have, each of them will have a frequency of x. So x, and return answer. We can use unordered map, but we want to find how many elements are there, right? If we can use unordered map, although like unordered map doesn't have a difference, only hashing is used. But if you're talking about a set, right, if you're talking about a set, in that case we also need to know how many elements, right? So if you stored, like if you stored the similar frequencies together or something like that, so what will you actually if you use a set frequency, uh, hmm, no, I don't think like no, we should not use a set. We should not use a set because yeah, because of the same thing, like we would not know how many elements are there whose frequency is greater than equal to x. There might be two elements whose frequency is 2, right, whose frequency is 2. So if it just stores one instance of 2, in that case we will not know that there are two instances of 2. We have to have that information separately. So just to prevent that, it's better to use a vector. Does it make sense? uh, Although her answer is not correct, in num elements into x, okay, x, I think we have calculated a bit more. So x is belonging to a, okay, and hash map of x plus plus, and after that auto v belongs to hash map frequencies dot push back v dot second, yes, and sort, we are sorting them, and then we answer is n plus 1, and lower bound, and number of elements will be what? N minus index. Index is so index is lower bound of frequencies dot begin, frequencies dot end, and x minus frequencies dot begin. So that is the number of elements, first index whose frequency is greater than equal to x, and number of elements having this index will be n minus index, I believe. Yeah, that should be true. So n minus total number of elements is n, and number of elements that are remaining, and each of them will have a frequency of x. That should work, right? N minus of element will have a frequency x, right? That should work. Somewhere we are doing something wrong. So let's see out num elements, right? Num elements and index and x. Compile and run. Sort the frequency and make it same as middle element. Sorry, get you. So 601. So num elements is 6. Index is 0. So for the first frequency it is 1, right? Index is 0, yes, and frequency is 1. So 601, and n minus so all the elements, so 6 is x is 1, and num elements is 6. All the elements are there, okay, and total number of elements is 6, 4, 3, 1, 3, 1, 2. That should not be the case. I think, okay, I got the mistake. So the number of elements is not n minus index, rather we are comparing on the frequencies array and we are doing n minus index. So frequencies dot uh, frequencies dot size minus index, frequencies dot size minus index. That should do. 2 is the answer, and our answer should also be 2. So that should do. 2 should be the answer, right? So here it makes sense, right? Frequencies dot size minus index. Why should it be n? Frequencies will have a different size than n, right? So like all the equal elements are grouped together. So we'll take the another example. So let's take this one as well. uh, how do we do it? Let's paste it here. 1 1 2 4 1 2, and how many elements are there? 1 2 3, 1 2 3 4 5 6 7, 7 elements. So 7, let's print my answer should not be n plus 1. That's why we have taken n plus 1, right? Answer should not be n plus 1. So we have taken an answer that is like, we are doing a minimum operation, right? So always the answer will become like, we are taking an initial value so that our answer is not affected. Initial value, that is not possible. So that's why we have taken n plus 1 initially. So answer will never be n plus 1, it will be replaced, right? So let's try to submit this. I hope this works. I'm not sure if this will work. Yep. So this is working, right? What will be the time complexity of the algorithm? Good question. What will be the time complexity? We are using a hash map to store. So a hash map will take, it's a map. So it will take order of n log n to store all of them. Then we are sorting as well, again n log n almost. And then again, it will be like all of the frequencies. We are again doing a lower bound, which is binary search log n. So it will be n log n again, right? So it will be overall order of n log n, right? All the operations are n log n. So n log n here, n log n here, and again n log n here. This entire thing, n log n. So the overall complexity will be order of n log n, right? And it was pretty simple. Like all you had to do was calculate the frequencies, and for each frequency find, if you kept that frequency, what is the number of elements you had to delete. So how would you find that? All the elements with the greater frequency, they can be like, some elements can be deleted and brought to the same frequency. The lesser elements has to be completely deleted. So you find the number of elements that will be there, that is all the elements whose frequency is greater than equal to x. Then all of them will have a frequency of x. So number of elements into x, and total number of elements was n. So n minus that many elements has to be deleted. So this is the code. Anyone has any doubts with this? And this is working as well. So any doubts with this? I think it should be clear now. Like, it's pretty simple. Actually, it's much easier than the last question, to be honest. So is this clear? Frequency long, no problem, Manav. Uh, Last part, could you explain again? Sure, no worries. So see, okay, what, up till this it is clear, right? We have stored the frequencies. Now we know that our answer, the frequency, not an answer, but rather x, right? X is what? The frequency by which all the elements will occur. X should be one of the frequencies of the existing elements, right? There's no point of taking a middle ground, right? It will always be better to take a frequency like of one of the existing elements directly. So x will be frequency of one of the existing elements. Now how we have found, so what do we do is we go through all the frequencies. We go through all the frequencies that are there of all the elements. Now let's say here what we have done is we have fixed a frequency. So we are telling that all the elements that will be there in the final array or the good array, all of their frequency will be equals to x. So the elements in the actual array whose frequency is less than x, let's say x is 2. So the elements whose frequency is less than 2, they can never rise up to 2, right? So they have to be deleted. So we just find, now what we need to find is how many elements has to be deleted. How do we do that? So we first find how many elements are to be kept. How many elements are to be kept, right? Or how many frequencies are to be kept rather. So we see that, how do we do that? All the frequencies greater than equal to x. So that we get using lower bound. So from lower bound we found the first index where frequency is greater than equal to x. Then num elements will be what? The total size minus index, that will be the number of elements which will be remaining. So we found the number of elements which will be remaining. We know what will be the frequency of each of the elements in the final array, that is x. So what is the total number of elements in the final array? Frequency, number of elements into x. What is the total number of elements deleted? It will be number of elements we started with minus number of elements in the final array. Yes, it is there, but just assume a case where multiple elements have frequency of 2, right? So let's say 1 1 1 2 2 2 3 3. Here you are telling that you want to keep a frequency, although this lower bound will actually not, is not necessary. You can take index, that will never become the answer, but it's always better to calculate it properly. When you are fixing a frequency of 2, what you are telling, we want to keep a frequency of 2, we want to keep a frequency of 2. So all the elements with frequency less than 2 will be deleted, right? These elements with frequency greater than 2 has to be there. So when you're selecting these two should also be there ideally, but you can definitely get rid of this, because the actual answer will be updated here only. This will give a more this will give a wrong answer although, but the answer will be more than the actual answer that will be we get here, right? So you can do without lower bound as well, that's not a problem, but it's always better to calculate the answer properly, right? So we want to keep a frequency of 2, so that means even if we are at this element, all these 2 should also be there, right? That's why we take a lower bound, but that's fine. Like we might actually not take the lower bound as well. We can just tell that the current index is like will not take, like when we are at this 2, we can always tell that will not take these twos as well before. That's totally fine, and the answer will become more, right? So the optimal answer will anyways get at this point, so that will also work. Does this make sense? Is this clear with everyone, how we are doing this? Right, so lower bound is not important, right? Like we can even do like this for, I have just calculated the answer properly. I equals to 0, I less than frequencies dot size, I plus plus, right? And we can like instead of this, uh, we can just do frequencies dot size minus I, and we can do n minus num elements into frequencies of I. That will also work. We don't have to do, so this will also work. But again, like this is not the right way to calculate, but again, like this will work because we always know the answer will be more in the later case, right? So this also works. This makes the code simpler, but not the right way to calculate, right? So again, like for the last loop, sure. For the last loop, what we are doing, let's say our frequency array is like this, right? So what we are doing is we are starting with 1. So if we keep the frequency of each element 1, how many elements will be there? So only the elements whose frequency is greater than equal to 1 will be there. So that will be given by num elements. So that is all these elements, 1 2 3 4 5 6 7 8. 8 elements will be there, and each of them will have a frequency of 1. That will be 8 into 1 elements will be there. How many elements did we start with? So that is the sum of this array, that is 3 plus 3 6, 7 8 9 10 11 12 13 14 15. So we started with 15 elements and we are left with 8 elements, so these many elements are removed. Let's say we go to this 2, right? We go to this 2, that time we see that how many elements will be remaining. Now the number of elements will be remaining is only these ones, cannot remain, right? They have a frequency of 1, they cannot be moved to 2. So number of elements remaining will be 1 2 3 4 5, that is given by frequencies dot size minus I. So 5 elements will be remaining and each of them will have a frequency of 2. So total number of elements will be 10. And how many elements were there? 15. 15 minus 10. So 5 elements were deleted. So this is a better answer, right? 5 elements are deleted. Here more elements were deleted. Next we can go to the next place, that is 3. For 3 again, number of elements will be there, that is 2 elements will be there. Each element will have a frequency of 3, that is 6. So 6. So here more elements will be deleted. So the optimal answer will be 5. Answer will be 5. Okay, anyways, I hope this is clear with everyone now. So, and the first question we are not solving again, like that's a pretty simple, it's a reversal of linked list. You should definitely do this yourself because it's very important when it comes to interview point of view, right? So thank you guys for joining in, and sorry for the inconveniences. I do not have control over the weather, so I'm really sorry about that. But anyways, but yeah, thank you guys for joining in, and I'll be seeing you next Sunday.